Well, hello, everyone, and welcome to another edition of the Better Satellite World, the podcast of Space and Satellite Professionals International. I'm Lou Zaccarella. Today, we wrap up our series, which has been following ground segment companies and technologies that have taken center stage in the satellite communications business. But first, this series is underwritten with the generous support of Kongsberg Satellite Services. You know them as KSAT. The Better Satellite World podcast is also supported by the corporate partners of SSPI, EchoStar Hughes, the law firm of K&L Gates, and Access Intelligence, publishers of Via Satellite Magazine, and producers of Satellite 2021 in September at National Harbor, Maryland. Additional support comes from the 3,000 members of SSPI and its chapters around the world. Thank you, SSPI. Well, the absolute revolution underway in the satellite industry has had unintended consequences. In a new report by World Teleport Association, the birth of teleport operating companies that own little infrastructure of their own, but take advantage of advances in cloud performance, advanced data distribution technologies, and new satellite-based applications has begun to emerge. Through tactical arrangements, fiber links, and advanced network management platforms, they aggregate demand from customers and leverage the capital investments of teleports and satellite operators to add value, a new kind of value, to service. They could be competitors to traditional teleports as well as strategic partners that bring new revenue to facilities-based operators. There are a lot of issues to go over, but today we examine this trend with three people who are in or right near the middle of it. And so I welcome to the Better Satellite World Christopher Boyd of Kratos Defense and Security Solutions. Mr. Boyd is the Senior Director of Product Management for Space, Earth Observation, and Sensing at Kratos, three profoundly exciting areas right now. Will Mudge is Vice President for Engineering Operations at Speedcast, where he develops global teleport and low Earth orbit strategies, another area that's exciting and in the middle of things. And Carlos Placido, a senior analyst with Northern Sky Research, NSR, one of the industry's most prominent research shops. His distinguished career includes a stint at Intelsat, where he identified, among other things, new SATCOM uses for emerging video and IP data technologies. So together, I estimate we have over 60 years of satellite technology, teleport, and strategic experience. And that doesn't make us old, it just makes us experienced, of course. And gentlemen, welcome to the Better Satellite World.
Thanks so much, Lou. Appreciate it.
Thank you. Pleasure to be here.
Well, it's great to have you. Hey, Carlos, I'm going to start with you. Can you describe for us and kind of set the table what is meant when we talk about a virtual teleport and what NSR sees when it looks inside this trend?
Sure, Lou. So, yeah, the concept of a virtual teleport is not really new, only that it has become more important lately because of multi-constellations and other developments. But I mean, the idea of a virtual teleport is that, you know, you move away from a teleport that is, you know, focused on transmission, essentially, right? And in many cases with kind of purpose-built or even proprietary hardware components. And you move away from that and you get more into software-defined, flexible, and extensible elements, right? So the idea is that the teleport becomes somehow, you know, a node of a more extensible virtual network infrastructure, not just, you know, again, about just a transmission node in the network. And it's not just about efficiency anymore, as we know, but it's more and more about kind of a coordinated approach towards, you know, how you deliver services. The Earth observation market is where we've seen this trend being very strong, although, as I mentioned, and for obvious reasons, but as I mentioned, now the emergence of multi-orbit and multi-band high-throughput satellite constellations is really making the traditional gateway/teleport architecture you know, unsustainable in terms of you know, scalability and so forth. So
yeah,
so that's kind of the idea.
Yeah, and again, you kind of just describe it as a disruptive element. I mean, that's, I think, what our listeners are going to hear when they see that, with, again, a lot of opportunities. And of course, I want to ask Will about the teleport presumption there, what happens to the classic teleport. But before I do that, I want to ask Christopher. Chris, your colleague at Kratos, Greg Quiggle, said in his introduction to a recent WTA white paper on virtual teleports that agility is needed in the ground segment to keep pace with these new capabilities. I read a similar thing in one of Kratos's white papers, which I think you may have written, called Enabling Dynamic Ground. So first of all, can you talk a little bit to this need for agility? And if you were advising an operator on this aspect for the purpose of a capital investment or a strategic acquisition, something like that even, how would you guide them? What's the best way around this today?
Yeah, great question, and thanks for having me. So, one of the things that I would want to make sure that folks understand is to look at their existing current operations, determine where they can leverage virtualization and automation, specifically to drive operational efficiency, as well as analyzing their hardware and software capex and telecom opex to look at the whole picture. There's a little bit of a misnomer in the industry that virtualization actually achieves a lower cost, right? A lot of times there's a toll to be had to get into the virtualization automation world. So it doesn't always initially reduce cost. And so one of the things you have to try and do is offset those areas where you have where you have expense and where you can leverage virtualization and automation to get the greatest ROI. The idea is that you can start to consolidate some of the functions, and by leveraging virtualization fabrics and automation capabilities, you really start to lead to this idea of operational efficiency, not just OpEx and CapEx spend.
Right.
And so I think what historically people have done is said, we're going to put this ground system in to solve this mission profile. And because of the financing of the spacecraft and the ground system typically being tied together, they put the whole thing in at once. And I think what we're seeing is that by leveraging virtualization and automation technologies, the ground system can scale up or scale down based on the service, and that allows for, I think, a pivot if the service needs to change mid-life cycle, or in the case of the Earth observation market, we're seeing a tremendous amount of small sat and new operators upstart. The teleport operator can pivot into essentially adjusting that ground segment, where historically a reinvestment in that would be quite difficult to stomach.
Right.
And then lastly, I would say, making sure they're tying back to some of the points Carlos made, which is, if I'm looking at these as opportunities for new types of teleports, make sure that you're creating them in a service-oriented fashion, so that as you take advantage of new bands, new orbits, new capabilities, new satellites, that you're oriented much like your customers are going to start driving their service, which is clearly a service-oriented approach.
Yeah. So I mean, what I'm hearing from you though is that operational and fiscal efficiencies are possible here, and you don't have to build for the next 2,000 years. There can be flexibility built into this. That's would kind of be the advice, right? If you were describing.
Absolutely. Yeah,
Yeah.
and I think that's part of the agility statement, and looking at the ROI of that agility is really what we want to take care of.
Yeah. Picking up on all of this, Will, you've got the opportunity to bat third here in the lineup. Listening to this, I mean, you are around teleports. I mean, the classic teleport that Carlos was describing, which might be evolving in another direction or out altogether. You've heard about the agility requirements, the efficiency requirements, or the efficiency capabilities. Where do you come down on the virtual teleport, having listened to this? Do you agree, first of all, with your colleagues, or do you have another view on it?
No, I absolutely agree with them, right? They're very correct, right? But I like to try to take a step back and maybe view the market in totality, right? Teleports are driven by the satellites that go up. Historically, there have been geosynchronous satellites, a really big, expensive satellite that goes up. You take one teleport, broadcast operations and the likes, and that's what's changing, right? The paradigm with these LEOs is evolving everything. When you look at Earth observation, it's a store and forward LEO. They have a package of information and they're trying to offload it as quick as they can, as well as a whole other group segment of LEOs that do about the same thing for store and forward, whether it's for IoT or for some other application. it's a really interesting market because you don't need a whole system of teleports to support it. You just need one teleport to start and a satellite, and you can start to provide a service. And as that service grows, you need more teleports to be able to offload the data because you can't get it all down at a single teleport. As well as an opportunity of, there's so many companies that can get into this because the cost point to get into those markets as a store and forward satellite is pretty low compared to creating a whole constellation or a geo. So what you see is the market scattered with many companies that have these store and forward constellations with a low investment peak, but maybe not all the money spent on the teleports to be able to support a growth model for them. So what Chris and Carlos are talking about, we're taking an antenna that's only going to be used for 5 minutes a day as the satellite goes over it, and then selling it to another company that can use it for another 5 minutes, and then another company for another 5 minutes. You've just tripled the use of that particular asset by virtualizing it and sharing it between multiple customers. So there's a lot of value in doing that because it makes good business sense for your CapEx investments in the long term. And that's where you see companies coming in. Now, the challenges come in with frequencies, right? The Earth observations have a very specific frequency set, as well as some of the other store and forwards have a different frequency set. And that's where this flexibility and agility comes in. So from an existing teleport perspective, the flexibility comes in. How do you save space to be able to support these? How do you get an antenna or the licensing to be able to bring these things up? Because they often want them in very specific locations as well.
Right. If I make sort of a classic teleport operator, yourselves, Arkiva, others, and I've got all these assets sitting around, or not sitting around, but I've got them, and I've had them for years. Does it make sense to be somewhat entrepreneurial and to look at joint ventures with some of the startups that are providing these services? Or I guess I would ask, if you were an entrepreneur and you were looking at this landscape, and would you say, I want a kind of a hybrid? I want something that's already in the ground, and then I'm going to create this kind of service element around it?
Absolutely, right. So like with our teleports, as an example, there's a mix of GEO, LEO antennas in the same yards, as there should be, right? It's part of it. As the industry grows, you add more capability to your teleport. So you're spot on, right? Companies like ours, it does change what a teleport's going to look like over the long term. But the reality is the GEOs aren't obsolete. They're not going away tomorrow. They're going to be there for a while. Same with all the antennas that are needed to support them. What we're seeing is a new market come in where you're going to need to build antennas to support them as well.
Right. And again, everything is getting shifted around. Carlos, I'm going to refer back to the WTA report again. It was noted by at least one teleport executive, people like Will, that the demodulation that normally happens in a box at the antenna right now might happen miles away at a data center. And someone commented in the report, that's a big shift. That's a reasonably big shift at minimum. What do you think it means from the perspective of the teleport or satellite operator first, but then more importantly, the customer? Is it going to be a really big shift for them too, or will it be seamless?
It is a shift. I mean, but you have to consider the fact that you have to be somehow there, have direct access to cloud compute resources, right? When you shift the modulation capabilities away from teleports, because probably Chris can speak better about this, because the whole thing about digital IF is that you can digitize the signal as soon as possible, right? So that you minimize the amount of or the number of elements you need to deal with. So I guess that also means higher data rates, which means that it is reasonable to shift again the demodulation away from the teleport. But I would say that what this means is that teleports will really need to increasingly look more like data centers, right?
There you go.
Yeah, right. That's where things are going. And that's the reason why I think that, especially when you think about, constellations, for example, I would not be surprised to see constellations deploying antennas on rooftops of data centers, right? Data centers will have satellite capabilities, and teleports will have to be, look more and more like data centers in terms of, having generic equipment that can do all the digital processing without the need of having, many different types of equipment that each one performs a specific function without necessarily, doing all that in a coordinated and flexible way, I would say.
Yeah. Just before I shift over to Chris to let him pick up on that, would we, when I ask about the customer, will we see any impact on pricing? Will they be getting, will operators have to price their services differently? Will we see lower prices, higher prices, different packages of services when we start putting our antennas on data centers and become information ports if we're a teleport operator like Will?
I mean, what we've seen so far, we do it today, right? We have antennas co-located at data centers, is it doesn't necessarily change the price point for the base service significantly, right? Where you gain the value is aggregating customers and utilizing an asset more, or the ability to, as a real world example, right? If we backhauled our RF to a single location, we wouldn't need to deploy as many new tech hubs for our networks, right? You could have one new tech hub in one place as compared to, 15 distributed around the world.
Right. Chris, you kind of lit up when we start talking about antennas and on data centers. Do you want to pick up further on what Carlos was saying, and then I've got another question for you.
No, I think absolutely Carlos hit the point. I was waiting for him to get there, and I knew he probably would. And from our perspective, right, it does get to the digital RF being the key to some of this work. And Will also touched on, I mean, once you've got sort of this digital RF, you can process it, then you can drive economies of scale where your processing is. And if we look at some of the Earth observation opportunities, right, some of this is getting it into the cloud as fast as possible. And I don't necessarily, when people say cloud, they always think like the public clouds, but there's also a lot of private clouds, particularly in some of the government missions that are secure data centers that are never going to be operated in some of the public architectures. But the idea is that there are whole new architectures being envisioned to take advantage of that, teleport on the top of the data center concept that Carlos mentioned. And this really starts to open up completely new ways to monetize, as Will was starting to say. It doesn't really change the cost for the downlink, but we can reprioritize the cost in other ways. It also, I think, allows for, and Carlos started to hit on it, Will, I think to an extent, is, even the ground service operators today have recognized that they have to do modulation, and some of them have acknowledged that that's a burden. I will tell you, their customers are saying it's burdensome for them to not be able to control their own demodulation for Earth observation markets. So the customers are asking for more control of the demodulation, particularly where it happens or how it happens. And so they're saying, I'm already doing workloads in places. I would like my demodulation to happen closer to my workload. And that's because either they're leveraging multiple teleport as a consortium or federation, or they're using multiple teleport downlinks for different downlink types. And so one of the things that we're seeing is that for the ground station or ground system as a service providers, they want to turn that service as fast as possible. They want to make those antennas basically run all the time. And part of the sort of tail of the downlink is the post processing. And so if they allow that to go to the customer, I think it does create some opportunities where the customers are willing to take on some of that, what I say in air quotes, burden. But I think there's all kinds of new architectures that we're seeing that digital RF is enabling. And it doesn't scare us at all.
Yeah, well, you're right. Yeah, Will, go ahead.
Yeah, sorry, I just want to say, I think it's important too to see that how this focuses with that particular market too. We can't, like we talked about, or I just mentioned doing new tech, right? You can't actually backhaul all the RF to one new tech rack because latency doesn't work well when you're doing the TXRX scenario. When we're doing kind of a one-way feed, works really well. I think the other thing to note, and Chris, keep me honest here, when you backhaul the RF as compared to backhauling a modulated signal or demodulated signal, it actually takes up more bandwidth on the backhaul too. You may spend more on the backhaul to get the RF back to the data center to do the processing locally, but you remove the need to have the processing at the edge, which does bring a lot of value. So I think people just be aware, it's not an easy P&L account to figure out exactly how to do it. There's trade-offs both sides.
No, you're exactly right. And I think that's why we're seeing that data center on the rooftop teleport kind of configuration, because they want to reduce that last mile transport as short as possible. And to your point, I mean, it's a lot more bandwidth. But if you're smart about, I would think in some of the two-way communications, if you're smart about how you lay out your infrastructure, we're not saying backhaul this halfway around the world. We're saying backhaul it from a couple of regional teleports to a central processing center. So.
Right.
Yeah.
Go ahead. Will, do you
I
want
was
to
gonna
pick
say
up?
makes
Yep.
makes total sense, right? There's so many values there too. Just because if you miss it at one teleport, you could catch it at another. You could stack. There's so many good reasons to do it. Just I think it's good to know the gotchas too, right? It does cost a lot in terrestrial backhaul.
Yeah. Carlos, as you listen to this, any thoughts on the pricing models and how, you know, these might again lead to more business, more revenues for some of the operators in the business?
Yes, I mean, the way, I mean, I guess it's no secret that the more you get into a virtual kind of environment, the better for, you know, as a service type of models, right? Where, you know, you pay per use essentially. And that is the case for Earth observation markets, as Chris and Will mentioned, that, you know, you use the resources on demand essentially. But it's also going to happen to some degree to SATCOM. It is happening, but I guess again, multi-band, you know, multi-orbit constellations will drive some of those shifts because, you know, when you think about virtual networks, it's not just about, again, transmission. It's about becoming part of a more like how do you say, more like an empowering ecosystem, right? And
Yes,
when you think about all the things that the cloud itself can bring into the satellite space, that's when you start getting into some interesting dynamics, right, between partners. I mean, that's one important point about the future, you know, virtual teleport. It's not just about a teleport. It's about, you know, part of a more comprehensive, you know, ecosystem of virtual services. That's the way, the best way to think about it, I guess.
Right. I mean, we're talking about digital hubs here, right? You know, rather than
Right.
some one thing. I just, I have to ask you, Carlos, just, and this is, you know, not a plug that anybody paid for, but I know you guys have a new report coming out, I think this week, called Shifting Sands of SATCOM Commodity Pricing, which I believe you authored or lead author on. Is that, do I have that right?
On the satellite capacity pricing, yes.
Yeah.
Yeah, and it's interesting, some very interesting dynamics. I mean, it's obviously we don't have the time to go through all of them, but long story short, you know, every application has its own dynamics. And, you know, you see competition, you know, HTS, wide beam, you know, all the looming VHTS and non-geo constellations. That report is focused on FSS band SATCOM essentially, right? I mean, and
Okay.
so all the major applications are covered by that report. Yeah, but thanks for bringing that up. Yeah, it's a very interesting report.
Yeah, well, I was thinking about it within the context of what we're talking about. Maybe, you know, do you factor any of this stuff in? But it doesn't sound strictly as the case.
No, yeah, we should focus on capacity pricing in that report.
Okay. Chris, I want to switch to antennas. Will there be added demand on antenna systems? I mean, will a teleport or teleports become more complex facilities going forward based on the model we're talking about this afternoon?
You know, I think today we're not seeing it's putting added demand on the antenna system in a classical sense. However, I think there is an increased focus that has to happen on the operational and systems that include the antenna. So, you know, to be clear for listeners, like we're not talking about the actual antenna, but the things that manage the schedule, pointing, you know, deconfliction of access to the antenna, you know, reset times, et cetera. And so there is absolutely a need to integrate the antenna as a part of the automation framework. It can't just be left off the, you know, out in the yard as well, put it, you know, to be just sort of like scheduled ad hoc. I mean, it really has to be a part of if you look at a service orchestration, you know, it's a key component, just as the digitizer is, as we talked about for the RF over IP domain, and any other of the virtual compute infrastructure components. You know, it needs to be a complete component of that.
Right.
So we do think that has to be, that there's increased focus on including and understanding antenna and antenna subsystems as a part of that, which includes obviously some of the pointing and electronics.
Right. Yeah. I guess what I was also getting at was, I know Kratos acquired CPI's antenna systems business a year or so ago, maybe a little longer. You know, given the environment that's changing so rapidly, do you guys anticipate that there may be more emphasis put on the R&D side to put new capabilities into the systems, or did you anticipate it already, being the smart guys that you are?
No, well, I think we did anticipate some of that, but I think in the context of overall teleport virtualization, the high capacity antennas are still hardware, or largely managed through hardware tools. But we are taking a fresh look at how the antenna integrates into the system, and we are looking in leveraging some of our capabilities and technologies to think about and rethink about the basic features of the antennas and how they integrate in the ground system. Strategically, we want to find ways to offer, exceptional performance for our customers, while also lowering the total cost of ownership. Right? That's all things that people consider. And again, a lot of the traditional points were that the antenna was bought and paid for as a part of the initial investment, and I think we have to look at that and balance that. But any particular details, I don't think we'd comment on at this point relative to the strategy.
Right. See, that's how I love our industry. We're also honest. So you could have said, of course, we anticipated this 10 years ago. Lou, we've been preparing for it. We're all ready to go.
Well, I do think there's one area that's going to change it, and that's an electronically steered technology, and that I think will revolutionize a number of aspects. When you go back to Carlos's comment about the rooftop of a data center, I don't imagine many neighborhoods who are co-located near data centers. They're probably already not very happy about it, but they don't want 9-meter antennas on the roof of those buildings visible. So I think the electronically steered antennas are going to add a high degree of flexibility and lower profile, but not to mention many of them are multi-band, multi-beam, simultaneous, right? So now we have to think about how do those technologies, and that's when I say we want to integrate the antenna into the overall scheduling and orchestration, it's really about how do we take advantage of those types of technologies for sure. So we're definitely keeping our eye on the developments and through our antenna group.
Yeah, and a little more orchestration of it would seem to me, of the hardware to accomplish some of the things we're talking about, which kind of leads me to my last two questions. What will the model we're talking about, the virtual teleport, where are the vulnerabilities in it? What would concern you the most if you were in that space investing?
I mean, we are in the space and investing, and the part that worries us the most is the preventive maintenance. Right. When you look at the vulnerabilities of it, you're moving from, the 9 meters track, right? But they're not moving nearly as quickly or looking at the arc or anything else as compared to, these 3.5 meters that we use in S and X band. Those tend to track a lot more. So our PM maintenance is much higher for it, the ability to fix something on it and make sure it's all ready to go. The other side that we see that concerns us is the ability to get licenses in these frequencies. The frequencies that they use are often really hard to get in congested areas like a city or a metropolitan area where you often find a data center. So it's a little bit hard to reconcile the two of them together.
Right. Okay. Yeah, that's fair enough. Carlos, last question to you. Is this model sustainable? And if so, how much does it scale over as we come out of COVID, as we continue to see Earth observation, geospatial businesses flourish, as cities continue to consume data at very high rates to run and manage themselves, as all these other vertical markets just sort of pop into our industry for the first time? Where does it go if it's as sustainable as we think it is?
It is. I mean, I think that there's no secret that the satellite industry as a whole has actually been a bit slow to jump onto the virtual network architecture and even open network architecture bandwagon. The terrestrial network has been doing that for many years. So it was about time that we all recognize that it's really the way to go, right? And as I said before, all these things are happening around multi-band constellations and high throughput is really making the traditional teleport architecture no longer scalable. So I'd say that's interesting to watch. Now, obviously, as you move towards a virtual network, you also need to recognize that the traditional stakeholders might need to shift a bit of their focus, right? I mean, but not necessarily completely. I mean, think about, for example, service providers, right? Like Speedcast itself. I mean, at the end of the day, their core business is about that close relationship with end customers and understanding their evolving needs. It's no longer just about owning all the infrastructure. In fact, large operators, both satellite operators and service providers, in fact, already share a lot of infrastructure, right? So I think we're moving towards an environment of more and more infrastructure sharing, empowered by software and virtual networks that allow people to interact more fluidly. So I think that will be the direction that everything is taking. As we said, EO or Earth observation was maybe like a leading case, but I think this is also getting more and more into SATCOM.
Right. Will, in a minute, do you agree, disagree? Have your own vision of it?
I think I disagree with that. It's going to change the teleports. Everything's going to go to a virtualized system, right? I don't think teleports have the ability to virtualize like terrestrial circuits do. I think SD-WAN and things like that are absolutely a key piece to it. But at the end of the day, you still need a physical antenna, whether it's an Earth observation LEO or whether it's a C-band broadcast system. You still need a physical antenna. You still need an amplifier. You still need an ACU. You could virtualize the ACU, but you can't virtualize the amps or the LNB. You're always going to need that physical infrastructure. And where you can save money is consolidating the stack, right? If you can get the modems, the routers, switches, firewalls, all of that virtualized into the hypervisor, if you could just backhaul the RF and put all of that in another location, I think all of that is legitimate. But when we look at the teleport model, you're still going to need geo satellites for quite some time, right? Intelsat's ordering new satellites, as is SES and Eutelsat. They still have customers for these things. So it's not going to do away with the need for 9-meter antennas.
Physical infrastructure is going to be here to stay, Chris. They're going to want antennas. They're going to need antennas no matter what. So you can be the neutral voice on here. Where do you come down on that discussion?
Well, I mean, I agree with Will. Right? You're not going to virtualize an antenna. I mean, obviously, there's going to be tremendous advances with the electronically steered technology, which will, greatly, reduce the footprint potentially, and also integrate them, as we mentioned before. But I agree with Carlos too. I think that we're going to see a lot more sharing of infrastructure, because a customer who may have had to backhaul their traffic out of the teleport to their own processing centers may actually now ask for co-location, processing of their workloads, whether it's a SATCOM workload, Will mentioned SD-WAN and terminating that into like the internet, or frankly, getting to Azure. Most enterprises now are on Office or Microsoft 365, so getting it to Azure quickly is actually one of the key things. So there, I think you're going to see a lot of sharing asks for them to and in the old days there'd be a co-location. Now they're going to say, hey, do you have some compute I can run on? And so I think it opens up new revenue opportunities for the teleport operators to actually host workloads, third-party workloads for their customers. And so I think when Carlos is saying sharing, not speaking for him, but those are the kind of ideas I take from that discussion. And certainly we've seen that already in Earth observation. And I do extend that. I do think that'll extend into other markets within satellite.
Yeah, I think that's very well said. Absolutely, this is the last question, and it's the most an important one. Have you guys, everybody been vaccinated? Carlos?
Yeah.
Not me, not yet.
Not yet. Okay. Chris?
Yeah, absolutely.
Will?
Not mine.
Got
Yep.
yours. Okay. So maybe we'll see 2 of the 3 of you, and by that time, Carlos will be vaccinated, and we'll see you in September at the satellite show.
Looking forward to it.
Yeah, sounds great.
All right. Well, listen, I look forward to this conversation. Now I know why. So I really want to thank you all because unfortunately we're out of time, but that concludes our series Safe Landing. And I'd like to thank Christopher Boyd, William Mudge, and Carlos Placido for their time. This was a very, very important conversation to have. This series is underwritten with the generous support of Kongsberg Satellite Services. KSAT is a leading provider of ground station services for satellites, rocket launchers, and experimental spacecraft. From 2018 to 2020, KSAT supported 95% of the commercial satellites launched into non-geostationary orbit. KSAT's network spans over 180 antennas at 20 ground stations across the globe. To get to know KSAT better, go to ksat.no. So that's ksat.no. The Better Satellite World podcasts are also brought to you by the 3,000 members of Space and Satellite Professionals International and our chapters worldwide. Additional support comes from our corporate partners, Eutelsat, EchoStar Hughes, Access Intelligence, and the law firm of K&L Gates. You can learn more about how you can support the Better Satellite World Series at sspi.org and get free content, entertaining videos, and listen to podcasts like the one we've had with Will, Chris, and Carlos today at bettersatelliteworld.com. And follow us on Twitter at SSPI and check us out on LinkedIn and Facebook. And if you're not a member of SSPI, we have to know why. Go to sspi.org, become one. It's $100 US per year. And if you're a student, your membership is free. For Space and Satellite Professionals International and our producer, Ana Gomez, I'm Lou Zaccarella. Let's make it a better satellite world. Take care, everybody.